start starting it. Yep. Cool. Inside. Some people. Donovan. Hey Donovan, how you doing? Right. Nice, yeah. We like the 4 to 5 week ban there, boy. We on approach. So, all right. So let's see who are doing what here. Right? So D'Angelo here. So Donovan here. Right. So Ziri here. Julie here. Khalifa here. Lower Island Page. Yeah, okay. Well, maybe that's everybody for today. All right, folks. Today we're going to kind of round off the coordinate geometry aspect of it with the word problems, right? So for the past couple of sessions, what we did is we took all of the coordinate geometry questions that had diagrams or graphs, right? So we used those questions to kind of get our intro to coordinate geometry. Well, the particle review of coordinate geometry, right? So we kind of went in order as well. So 2017, 2019, 2020, right? So it was kind of a mix between January and May. The actual questions here. So these are the ones we did before. So every time we do a question, I'll print it out, give it to all you, and we go from there, right? So that way we kind of work in the same, well, I want to say the same pace, but not exactly, right? So today, what I want to show you is we have some questions where instead of diagrams, they give you just like coordinates and words and these things, right? So this one is the Jan 2018 question. Hold on. Did I continue the second page? No, okay, so Jan 2018. Let me print the current page. Oh, who's that? Oh, it's D'Angelo. Hey, Danico, how you doing? Dial vibes. Hey, D'Angelo, evening, how you doing? All right, 1, 2, 3, 4, 5, 6, 7. Let me do 8 copies. Current page, 8 copies. Right. Marie, okay, hot. Right. Did it go to print? Did I send it to print? Yeah, the printing. All right, cool. And of course, what I need to do, of course, is just kind of copy and paste the business. So let me do that. Who that? Hey. I am supposed to. Just give me 1 second. Oh, yeah, Bella Khalifa online. All right. Oh, look, my lovely wife, honorable wife. Hello. And good evening, Hanifa. How are you doing? Right here. Okay, cool. Right, so everybody have a copy of the page, right? Okay, so give me 1 second. Let me actually just put this aside. All right, I just want to copy and paste that whole thing. This is the Jan 2018, right? Okay, cool. All good? All right, glad to hear that. Yeah. Just a little late today, but that's all right. Got to copy and paste the questions, and then we get to go. Insert screen clipping. All right, cool. Yeah. Okay. Right, so John 2018. First thing that they want here is it says the equation of a straight line L is given as 3x minus 4y is equal to 5. And normally we know the equation in what form? This form right here, y equal to mx plus c. And that's the form in which they want us to state the equation. All right, so let's zoom in a little bit more. Cool. So basically what you have to do is transpose. You have to take this item here and make y the subject of the formula. All right, so I'll give you a minute or two. Really, the eyes open up big, everything all right? Fine? All right, cool. So I'll give you a minute or so. Right, those who are not sure what to do, well, just hold on a minute. Try not to go on your phone. Huh. Mm. Where is my YouTube? Right, you in live control room. So I should be able to answer any. Viewers. 6. We have 6 viewers on YouTube. Hey, YouTube, what are you doing? Right. Alright, I'm gonna let these girls out and then we'll start here. Oops, sorry. Where'd it go? All right, okay. Hold on. Who's that? Who's that? The boy? All right. Hold it now. Yeah. He's a silent one. Okay. All right, guys. So, user 00. Oh, you're welcome. Thanks. Thanks for thanking me. Appreciate it. Right. So let's start with the 3x minus 4y equal to 5. And we want to make y the subject of the formula, and we want it to be in this particular form here. All right. All right. So you want a positive y. Now you have different ways you could do this, right? So one way is let's carry over the whole 4y. Now, how is the 4y attached from this? What operation is this here? That is subtraction. How do we remove something attached by subtraction? We use the opposite operation, which is addition. So what's going to happen here? We're going to add 4y to both sides of the equation. So let's show it along with all the gory details in these things. So we're going to add 4y to both sides of the equation, right? Now, when you have minus 4y plus 4y here, it cancels to 0, leaving us with just 3x. And then you have 5 plus 4y, right? Which we could also rewrite as 4y plus 5. Now, again, you want y by itself. So let's remove whatever's attached to the y. What about the 5? How is the 5 attached? By addition. How do you remove something attached by addition? Use the opposite operation, which is subtraction. So we're going to minus 5, again, from both sides of the equation. So you're going to minus 5 on the left side, as well as minus it from the right side. So, of course, 5 minus 5 here will cancel to 0, leaving us with 3x minus 5 equal to 4y. Now, of course, we could also write this as 4y equal to 3x minus 5. And the last thing to do is to remove the 4. How is the 4 attached to the y? What operation? Multiplication. How do we remove something from multiplication? We use the opposite operation, which is division. So we could divide by 4, again on both sides of the equation. Now 4 will cancel with 4, leaving us with y. But how do we deal with that particular item here? Right, I've carried this across to the next side. Right? So the long story short is that basically to get this across to the next side, you have to do the opposite of the operation. The opposite of subtraction is addition. So when we add 4y to both sides, like I did here and here, right, I maintain the equality, right? Because whatever happens to one side must happen to the next side, right? But when I add 4y to minus 4y, it cancels to 0, canceling out. All right? I'll show you the next way after, right? Right, now this particular item here, how we deal with that is we do what's called decomposing the fraction. What does that mean? Right? It simply means expressing each aspect of the numerator separately over the common denominator. Long story short, you're going to have 3x over 4 minus 5 over 4. Right. Now, you can also express it as y. So you could pull out the 3/4 as a coefficient of x and have minus 5 over 4. You can put minus 5 over 4, you can put minus 1 1/4, minus 1.25, it matters not. This form is perfectly acceptable here. All right? So that's one way that you could do it. Oh, you guys gone? All right. All right, sorry. Okay. So, like I said, that's one way to do the transposition. Now, there are different ways that you can do the transposition. Let me copy and paste this. All right. Let me zoom back in here, and what we'll do is we'll just we'll delete everything here. All right, cool. Right, so let me actually get a different color here. Right, so if we bring back the equation, 3x minus 4y is equal to 5, and you want to transpose for y. Now, again, across here in the pink, I moved across the minus 4y, moved across by adding it to both sides, hence creating a positive coefficient for the y term. Now, some people like to leave the y term on the left-hand side. You can do that, but you have to be careful how you do it. Now, what's attached to that 4y? 3x. Now, the question I normally ask is, how is it attached? And you say, well, there's a minus sign between them. But are we subtracting the 3x or the 4y? On that side, we're subtracting the 4y. That comes after the minus sign. So what sign would be understood in front of the 3x? If no sign is there, positive is understood, right? So another way you could write this is minus 4y plus 3x. Right? Now here, if you want to, again, transpose for y or make y the subject of the formula, you have to remove everything currently attached to the y. All right? And I like to say, start from the point furthest from the y on the same side of the equation. So the minus 4 is kind of stuck upon the y by multiplication, so not that one. So the 3x. How is the 3x attached on that side? What operation? Addition. How do we remove something attached by addition? We use the opposite operation, which is subtraction. So what we'll do to quote-unquote get rid of the 3x on the left-hand side is to subtract it. And whatever happens on one side of an equation must also happen on the other side. Now here, if you have 3x minus 3x, what do we get? We get 0, leaving us with just the minus 4y on this side. Now on this other side, hey, you could rearrange this to do minus 3x plus 5, sort of like how we did this. All right. Now, the last thing attached to the y is the minus 4. How is the minus 4 attached to the y? Multiplication, right? And how do we remove something attached to multiplication? Correct, the opposite operation, which is division. So you could divide by minus 4, again, on both sides of the equation. Sorry, both sides of the equation. Now, a minus divided by a minus is a plus, leaving us with y. Now, again, what we'll do here is we'll decompose the fraction. What does that mean? It means splitting the numerator separately over the common denominator. Now, check this. Again, you have a minus divided by a minus. And what does that give you? A positive. So what happens is the 3 in minus 3x over minus 4 becomes positive. 3x over 4. And here, you have a positive divided by a negative. What does that give you? A negative. So this becomes minus 5 over 4. And again, finally, you can simply separate the 3/4 from the x like this, because multiplication is understood, right? Okay. Right. Ha multiplication should become correct, and titi talent divide. Very good. Thanks for participating, guys. Appreciate it. Right. And as you can see, we get exactly the same answer we got in the previous page. All right. So there's more than one way to go about solving. There are other ways as well, right? We could move the 4 first, the minus 4. We can move the 3 first, right? But all of those will be a little messier, right? Okay. So let me start. So D'Angelo, Donovan, and Hanifa, if you guys are good with what I showed you, just give me a quick. If you're good with that, give me a Genie chat. If you need me to re-explain, give me an R. All right. Please answer. Let me put up Hanifa is present. And Josiah is also present. Alright, so Liam and Logan, no. I gotta find out from them. Let's see, and Jaden and Javier. Juliana said she can't make it today. I think I should withdraw as a Christian. D'Angelo? Oh no, D'Angelo is here. We're talking about. Okay, so that's everybody, so I don't worry about it rolling. Alright, lovely. Okay, next piece here says to determine the gradient of a line. Now, when the line is in this form in the yellow here, which of those letters represents the gradient? Which of these letters here in the yellow represents the gradient of the line? M. Very good, Leo. So M, right? And here now, if you have y equal to m by x plus c, what's the value of m here? 3/4, 3 over 4, right? So the gradient of the line L is simply, sorry, one second, let me see if I can put a better shaped arrow than that. Oh, okay, I thought it would have automatically, yeah, like that, see? 3/4. All right, look. Look it. If flip it to do what, boy, Leo? Well, let me take a look. Maybe you anticipating. Okay, so the point, next piece here, says the point with coordinates R2 lies on the line L. Determine the value of R. Now, check it. Let's take a little reread and see what it's saying, right? So this point P with coordinates R and 2. Now R, so every point has 2 coordinates, an X coordinate and a Y coordinate, right? The X coordinates come first, the Y coordinate comes second. So in this particular case here, which item here is the X coordinate, R or 2? R, which makes 2 the Y coordinate. And it lies on the line L, right? And the equation of line L we just saw was y is equal to 3/4 x minus 5. So let me just reset it. So y is equal to 3/4 x. Was it plus or minus? It was minus, sorry. Minus 5 over 4, right? And here they said determine the value of r. So what they are asking us to do, right, is to find correct smiley face, yeah, is to find the x coordinate. So they want us to find the x coordinate given that we have the y coordinate. So how are we going to do this? What's the next step? What's the next statement after writing? What am I going to substitute in to facilitate the solution? The 2. In place of what in the equation? In place of y. So this will become 2. That'll be equal to 3/4 x minus 5 over 4. Right, I'll give you all a minute or two to see what you can come up with that. With 42 people watching, wow. That's not the biggest yet. Level on YouTube, boy. All right. YouTube. No problem. I have to go with the comments on YouTube. Sorry, let's answer my wife real quick here, right? GA paper is this? This is Jan 2018 question. Okay. I'm not sure which question, but it's either going to be 3 or 4. It's the coordinate geometry aspect of the paper. But Jan 2018. Look. Big head. Who's the only thing is shaking? Buckley of Bermuda. Hello, Bermuda. Mora, hello, Mora. Kia. Everybody. Thanks for watching. All right. Okay, so in a minute again. All right, cool. Now there is another way to solve for this. Eh? What was the original equation they gave us? Mm-hmm. That's correct. So if you want, you could actually go back to the original equation, 3x minus 4y is equal to 5. And you could sub the value inside of here. And that might be a bit easier, to be honest, yeah? Well, all right, cool. Right, so I'll give you a minute again and see what you come up with. Thanks, TikTok. Hey, Nikki, how you doing? Vibes. Thanks for following. But thanks for sharing. Drea, thanks for following. Certified bandit boy. That's a bad one. Right. Johnson, was he there? Oh, all right. Okay, I know he's here, boy. Pressure. All right, let me take a swing there. What's 4 by 2? 4 by 2 is 42? All right, cool. Right, so if 3x minus 8 is 5, so some number minus 8 is 5. So how do we find that number that we minus an 8 from? Right? We subtract an 8, right? Okay. Correct. So what we want to do is we want to add back 8 on both sides of the equation. Minus 8 plus 8 will cancel to 0, leaving us with 3x. And 3x will be equal to 13. And how do we solve for x now? How is it attached here? It's multiplication. The 3 is attached to the x by multiplication. To remove something attached by multiplication, we use the opposite operation, which is division. Right? So if you want to see it slightly longer, right? So you could show 3x being divided by 3. And of course, whatever happens on one side of an equation must happen on the next side. Right? So of course, 3 will cancel. So therefore, x would be equal to 13 over 3, or 4 and 1/3. Right? Yes, Mora, divide. Very good. Right, so that was the easy way to work it, to be honest. Then now, if you did it the other way, which is perfectly fine. All right, so what we could do first is, like here, you could choose to, well, as I like to say, clear out the denominator. So we can multiply by the common, well, yeah, the denominator on both sides, right? So when you multiply by 4, 2 by 4 is 8. When you multiply this by 4, it'll cancel the denominator, giving us back x. When you multiply this by 4, it'll cancel the denominator, giving us back 5. And we basically have the same exact, actually, well, not the same, sorry, but it's an equivalent statement, right? So because here you're subtracting 5 from 3x to get 8. So what we'll do is we'll add back 5 on both sides, right? When you add back 5 on both sides, you get 13 is equal to 3x. And now to solve for x, you have to remove the 3. How do we remove the 3? By division. All right? We use the opposite operation that attaches the item, the coefficient to the, the variable. Yeah, sorry, the word took a little long to register in the brain there. Okay. Ladies, we okay with that one there? Any questions? I see you pondering something very intensely there, Julie. All right, you sure? Or you just can't see the board, which one? If you get your glasses home. Yeah, I multiply by 4 to get rid of the denominators. Right? Because I have a minus 5 here. Okay, no problem. All right. Ladies and gents to my right, are we okay with the work in there? Any questions, anybody, anything? All right, cool. Google me. So D'Angelo Donovan Hanifa. If you guys are good with the blue and or the orange, just give me a quick G in the chat. If you need me to re-explain anything, give me a R. And if you could let me know specifically what you want me to re-explain, I would help. Okay, cool. Hanifa, you'll let me know, right? Whenever you get a chance. Sorry. All right, next piece. Right, find the equation of the straight line passing through the point 60, which is perpendicular to L. All right, cool. Perpendicular to L. When two lines are mutually perpendicular, what does that mean? They meet at an angle of what? Right.
Oh, 90 degrees.
Correct. When two lines are mutually perpendicular, that is that they are perpendicular relative to one another. Oh, look, Eri, Mora, and Stonaville. Yes, very good. Good stuff, man. Good job. Right. So hold on. Right. So this is line 1, right? And this is line 2. Right? So we let the gradient for line 1 simply be m1. And we let the gradient for line 2 simply be m2. Right? And there's a relationship between the gradients of perpendicular lines. Anybody remember what it is? If you multiply the gradients of two mutually perpendicular lines together, we do get -1. That is correct. Right? So what we're saying here, right? That's just kind of reestablishing what perpendicular means. All right? And the relationship specifically between the gradients of the perpendicular lines. Now, what is it they asked us for initially? They want the equation of the straight line, right? And we did that in the first thing, right? What is the equation of a straight line? Y equal, now one form is this. There are other forms. What is the one we like? Y equal to mx plus c, where m is the what? Where m is the gradient and c is the y-intercept. Now, this point through which it passes here, this is an intercept, but is it the y-intercept? No. Why and why not? Because the 6 is the x-coordinate and the 0 is the y-coordinate. If you were to pass through the y-axis, at any point on the y-axis, x is 0. So what that means is that since we have a y is 0, that's actually on the x-axis. So what they've given us is actually the x-intercept. But again, ahead of myself. All right, so let me come back here, right? So check it. We need the gradient of this line. And we know it's perpendicular to L. L is the line above. And we have the value of the gradient of L. So if we have that value, right? So if we have, no, it don't matter. Let's just put M1, right? Right, by 3/4. So 3/4 is the gradient of the line we have. So if you want to find this value here, what would you do to this equation to solve for M, therefore? You would divide what? Or by what specifically? Correct. You would divide by 3/4 on both sides of the equation. Why? Because again, we're trying to solve for M, well, M1. To do so, you have to remove what is currently attached to it. How do we do that? You look at the operation that attaches it, and we use the opposite operation, right? So M1 would be equal to -1 divided by 3/4. Now, what's the protocol for division of fractions, ladies and gents? You change divide to multiply, and we invert or flip the divisor, right? So now when you multiply in fractions with the protocol, you multiply numerator by numerator, and then denominator by denominator. So minus 1 by 4 is just minus 4, 1 by 3 is just 3. So the gradient of the perpendicular line for which we are now finding the equation is, the gradient is this here. So that is our M1. Now, it didn't matter if you put it as M1 or M2, it don't matter because we have one gradient, we want the other one, all right? So now, when we come across here, and we want to use y is equal to m by x plus c, where m is the gradient, x and y are any points, the coordinates of any point through which the line passes, and c is the y-intercept, right? What do? We substitute, because we have m, an x, and a y. So all we're missing is the c. And what we do is we substitute, simplify, and solve for c, and then state the equation outright. Okay, so the y value, or the y coordinate rather, given to us is 0, right? M is the gradient, which we just found down here, which is minus 4/3. X, the x coordinate is 6. Right. Okay, so 3 goes into 6 how many times? 2 times, right? Minus 4 by 2 will give us what? Minus 8. And if minus 8 plus c is 0, to solve for c, we just have to carry over the minus 8 to the next side, which will make it positive 8. For the more accurate thing, you add 8 to both sides of the equation. So what we have here is we have the value of c. So now we could go back and outright state the equation of the line. So therefore, right, the equation of the line, then the line, and I write in line, yes? Brushing it down. Is a line, that's a dyslexic lion. Like, no, that's not what it is. So the equation of the line is y equal to m, the gradient, which is minus 4/3 by x plus c, which happens to be 8. Yeah. If you put 6 for y, you mean for the equation line? Yeah. That's a good question. Well, okay. They didn't state a specific format, but they're usually acceptable ones. This is one of them, right? If you put the values inside, I would lean towards no, that I wouldn't give it at least the full mark, because the equation of a line is a relationship, a function, connecting the x and the y variables. So what you want to show is that whatever value of x or y is connected here. So the only numbers you really want are those two numbers there, right? But if you put, let's say you put the 0 here and then minus 4/3 and then bracket 6 and then plus 8, your statement is not mathematically incorrect. Your statement is mathematically sound. It's just not the usual acceptable format in which you wanted the answer, right? That's how we get the answer, right? It's like, for example, hold on. Yeah, let me leave it there for now, before I overtalk, right? Hey, Dex, what's going on, boy? Oh, you, I'm not sure. All right, okay. So once again, the equation of a straight line is usually given by y equal to mx plus c, where m is the gradient and c is the y-intercept, right? Now, they only gave us one point through which this line is passing. To find the gradient, we either need the graph to extract multiple points, or we need 2 points. You just need 2 points to find the gradient of any given line, all right? Now, since we don't have a second point, what are we going to do? Well, that's where the part highlighted in yellow comes into play. This line is perpendicular to L. What is L? That is the initial line that occupied the first 3 questions, right? Now, we found the equation of L in this form, y equal to mx plus c. We extracted the gradient, and then we found something else, right? Now, if we know the two lines are, as I say, mutually perpendicular, they are perpendicular relative to one another, there's a relationship between the gradients. If you multiply the gradients of two mutually perpendicular lines together, we always get -1. Now, what that means is if you have one of the gradients and you want to find the gradient of the perpendicular line to it, all we have to do is take minus 1 and divide it by the gradient we have. Why? Because if I'm multiplying these two things to get that, and I have one of the factors, to find the second factor, I just divide by the factor I have on both sides of the equation. While some people like to say, flip it and change the sign, which is essentially what we did. We flipped the 3/4 from 3/4 to 4/3, and then we invert it, we change the sign, right, from positive to negative. And then we use that in conjunction with the coordinates, the one pair of coordinates they gave us, right, in order to find the equation. So we substituted the values we had into the y equal to mx plus c. We simplified and solved, and then we stated the equation outright. Right? Don't forget that last part. It might only be a half mark, maximum mark, but you still want to get all the marks that you could possibly get on the paper. All right. Okay. All right. So D'Angelo, Donovan, and Hanifa, if you guys are good with this part 4, right, just give me a quick G in the chat, please. And if you need me to re-explain, it's not a problem. Just give me an R and tell me specifically what you'd like me to re-explain. Happy to do so. All right. Okay. Okay, thank you. All right. But in class, people, are we okay with part 4 on the screen there? Does anybody have any questions, issues, problems you want to clear up? You okay? Okay. Okay, so let's go back to the next question. So this is just an alternative working for the previous part there. Right, okay, so sorry, give me one sec. Right, so that was Jan 2018. So the majority of the questions, we do Jan 2019? Give me one sec. Yeah, we did Jan 2019. Aha. May 2019. Okay, cool. All right, so I'm going to print this out for those in class. Those online. I'm going to zoom in. I'll send a picture in chat, right? Right, where's the last speaker? Right, so this is a May 2019 question. Right, it's actually pretty short, so I might add something to kind of spice it up. Let me just distribute what I have. Right, so it reads the equation of a straight line is given as x over 3 plus y over 7 equal to 1. So this is another form of the equation of a straight line, right? And we know it's a straight line because the x and y, the power to which they are raised is just 1, and they're each a numerator, and they're being added together, not multiplied. One isn't being divided by the other, and that kind of stuff. All right, now it says this line crosses the y-axis at Q. Determine the coordinates of Q. Now, when it crosses the y-axis, what do we call that? The y-intercept. Now, when it crosses the y-axis, it means that the x-coordinate at that point is 0. So if you want to find the coordinates of Q, all you have to do is plug a 0 inside here. Sorry. And then what is the gradient? To find the gradient, right, you can either find a second point on the line, which the easiest one might be the x-intercept by plugging in 0 here, and then you could use your regular equation formula, y2 minus y1 over x2 minus x1. Or You could convert this into the form y equal to mx plus c. Whichever one you want to do, I'm going to do both. All right, so I'm just giving you a couple of minutes to get a head start, to make your little mistakes, have your challenges, ask your questions, should you have any questions. Let's see. All right, cool. YouTube. Appreciate it. I can take this off. I don't need that. Back up now. What days do I go? Like Monday and Wednesday, 4 to 6 is PUA, half 6 to half 8 is math. I used to have an ad maths on Tuesday and Thursday, half 6 to half 8, but my assistant is handling the ad maths class now. We go through those, but I have replays. It's not public. Um, Saturdays I have a 10 to 12 keep accounting unit 2. And my YouTube channel has all the lives for the year so far. So you can always check it out. But the crash courses are coming up. PU is next week. The maths, that one a little tougher. Yo. To determine the coordinates of the y-intercept, yes. Yeah, or you'll find y. Just in where do I get the questions? Right. So, sorry, YouTube channel name is the same as this channel, same name. It should be in the bio as well. I should have a link to there. Right, Chaos Incarnate. I have friends who collect and share papers. Long story short, right? They get them from other people. Who's getting from other people? That's just how it goes. Could I send what the question people? Well, this is a PDF with a compilation of the coordinate geometry questions from like 2015 to like 2019 to 2023. Shondell. I don't know how to send stuff in TikTok, like the TikTok live. I don't know that I can. Um, that would be a good thing to try and figure out. Was that the past papers? All right, here it is. You only email me. I think I could sort you out tomorrow, right? I give link or something. Yeah, I have a YouTube name. Yeah, that's it. Same adaptation. Okay, cool. Yeah, Mora Lux. So I have a second Mora. Okay, cool. Well, thanks for the follow, guys. Appreciate it. Wow. Yeah, cross 6 hours the other day. Trying to get to 10. Trying to get some creative tools open to me. I know how to make more content. I'm trying to find a way to do that, boy, but I have a 2.5-year-old and a 5-month old. So my time is very, very much not my own sometimes. Anyhow. All right, guys, let's jump. Oh, I have to copy and paste the question. So this is the May 2019, right? Okay, cool. So May 2019. Hey, give yourself a hand. Oh. All right, cool. Insert screen clipping. That's the whole question, right? Gradient. Okay, cool. All right, one sec. Let me just clean up some stuff a little bit. Right, so that's not what I wanted to do. Stop it. Isn't it more humble? But humblest sounds like a word. He's the humblest of them all. I don't know. I sound like a kind of fourth rate superhero. I am the humbler. Right. Okay, cool. Okay, right. So the line crosses the y-axis at Q, determine the coordinates of Q. Okay, cool. So we said when it crosses the y-axis, that's called the y-intercept. And on the y-axis, at every point, x is equal to 0. So what we're going to do is substitute 0 in place of x here. So 0 over 3 plus y over 7 is equal to 1. Now 0 divided by anything is equal to 0. And when you add 0 to anything, you get back that which was added to the 0. So here now we have y divided by 7 is equal to 1. What's the only number you could divide by 7 and get 1? 7. Or you could say, all right, since 7 is we're dividing by 7, we can multiply by 7 to get rid of the denominator. And of course, 1 by 7 will still give us 7. So the coordinates here of Q, right? Who? Oh, I was like, not me. Was it what? Right. So right. 0 divided by 3. 0 divided by anything is 0. Just like 0 multiplied by anything is 0. Right, coordinates of Q. Right, so that's how we find the coordinates of Q. Now the next thing they want is what is the gradient of the line? Okay, now as we know, gradients, we have a couple ways to do it, right? So one way, the conventional way, is the formula. M is equal to the gradient, which is M, is equal to the change in Y divided by the change in X. So we need 2 points. We need 2 sets of coordinates, right? Now we have one set so far. Now, what is this? This is the y-intercept. And we found that by substituting x equal to 0. Because at every point on the y-axis, x is 0. So the other easy point to find is actually what we call the x-intercept. And you could find that by subbing 0 inside of here in place of y. All right, so what you could do, you could say if y is equal to 0, then x over 3 plus y over, sorry, not y, plus 0 over 7. So I'm substituting 0 in place there, right? Is equal to 1. Now, of course, again, 0 divided by anything is just 0, right? So 0 over 7 is 0. And when you add 0 to anything, sorry, you just get back that which was added. And if x divided by 3 is 1, what's the only number you could divide by 3 and get 1? 3. Or you could say that we're dividing by 3. So to get rid of divide by 3, we use the opposite operation, which is multiply. And when they multiply by 3, you're just going to get back 3. So our, sorry, hey, whoa, right. So our x-intercept would simply be 3, 0. And what you could do now is you could use that, the blue, in conjunction with the pink, up in the green. Right? So this come like your x1, y1 across here. And this come like your x2, y2 down here. Right? So y2 is 0, y1 is 7. So you have 0 minus 7 all over x2 minus x1 as 3 minus 0. So we have minus 7 over 3. And that's the answer there. That's the equation. Sorry, that's the gradient of the line. Right. There's a second way to do it, which I'm going to do shortly, but let me just get some water in my system first, right? Keep again to drink enough water. Not a good thing. Right. So that's one way to do it. So I'll give you a minute again to copy down if that's what you're doing. And then I'll do the other way. Rat. Darling, where? All right, sorry, still a little recharging. Okay, so I'm gonna scroll down a little bit. I want to know what is the gradient of the line, right? Okay, cool. So it was x over 3 plus y over 7 is equal to 1. Sorry, that's not a 1, that's a 7. Equal to 1, right. Now, what we could do is we could put this in the form y equal to mx plus c, because here, which of those letters is the gradient? The m, the coefficient of the x term, right? So now, let's see if we could actually, I'm going to give you guys a minute to get a little head started. Let's see if you can make y the subject. Right? If not, don't worry, we're going to go through it, but try. Right? Remember, to make y the subject of the formula, you have to remove everything currently attached to it. What might help, right, is you could always rearrange this side as this. And we could do that because addition is commutative. What does that mean? What's 2 plus 3? 5. Exactly. 2 plus 3 and 3 plus 2 mean the same thing. So you can switch around stuff that's attached by addition anyhow. All right? Ready? Okay, so if we want to make y the subject of the formula, we need to remove everything currently attached to it, right? Now, what's currently attached to it? Well, first thing is y is being divided by 7. And then after that, we're adding this item to it. So we go in reverse, right? That's the easier route, to be honest. You could start by removing the denominator. You could do that. But, actually, let's do it both ways. Let me just show you that it could be done, right? All right, so what I prefer to do is I'll get rid of that first. It's attached by addition. How do we remove something attached by addition? We use the opposite operation, which is subtraction. So we're going to minus, sorry, one sec. We're going to minus x plus 3 from both sides of the equation. So we're going to minus it from this side. And whatever happens to one side of an equation must happen to the other side as well. Right, so x over 3 minus x over 3 is 0. right? So that'll cancel this side here, leaving us with just the y over the 7. And 1 minus x over 3, you could leave it like that, or you could rearrange it as x minus x plus 3, minus x over 3, sorry, plus 1. Right? Now, the last thing to get rid of is this denominator here. How is the denominator attached to the numerator? What operation? Division. And how do we remove something attached by division? By multiplication. So when they multiply by, so let's show the long working. So y over 7 multiplied by 7 is equal, so we have to multiply this whole thing by 7. So 7 multiplied by minus x over 3 plus 1. So of course, on the left-hand side, the 7s will cancel, leaving us with just y. On the right side, we have to use now distributive law. So 7 by minus x over 3 just becomes minus 7x over 3. And 7 by 1 is just 7. And of course, from here, sorry, one sec. Right, from here now, you could separate the minus 7/3 from the x like a coefficient. And that is your answer right there. That is the gradient of the line. Huh. Right. Google Meet, just Donovan, D'Angelo, and Hanifa. Just give them a quick G if you're good with that particular item. I'm going to do a second version to just now, right? Donovan, D'Angelo. All right. I know Hanifa's still floating around. All right. In class, people, are we okay with that transposition? All right. So I'm going to show you an alternative, right? So again, if we start off with the same thing, x over 3, sorry, plus y over 7 equal to 1. And you want to make y the subject. So again, if you want to, you don't have to do this part. You could just kind of change the sequence of appearance here. Now, you could remove this 7 first if you wanted to. How is the 7 attached to the y? We're dividing by the 7. To remove something attached by division, we use the opposite operation, which is multiplication. So you can multiply by 7, but you have to multiply everything by 7. So if you want to see it long ways, so the y over 7 is multiplied by 7, right? The x over 3 is also multiplied by 7. And of course, whatever happens to one side of an equation happens to the next side. Now here, the 7s will cancel, leaving us with just y. Here, you basically have 7 over 1. And when they multiply in fractions, they multiply numerators together and then denominators. X by 7 is 7x. 3 by 1 is 3. And of course, on the right-hand side, 1 by 7 is just 7. And the last thing to do to make y the subject is you want to remove the 7x over 3. How is it attached? Addition. How do we remove something attached by addition? We use the opposite operation, which is subtraction. So if you want to see it long ways, we'll subtract it from this side. And whatever happens on one side of an equation must happen on the next side as well. Sorry, again, I'm a little tired. Yeah, creeping back in there. Okay, so of course, here, 7x over 3 minus 7x over 3 will cancel to 0, leaving us with y. And of course, on this side now, what we'll do is we'll switch across the items, we'll swap them, right? Put the minus 7x over 3 first, and then of course, last but not least, you could, again, separate the minus 7 over 3 from the x, like the coefficient it is, and show specifically that that is the coefficient of x when it's in the form y equal to mx plus c, where m is the gradient. Right? So again, you have multiple ways to go about solving things in quite a number of instances. Right? So don't confine yourself to one particular technique. Right? I mean, if something is working for you, right? If it's working for you, by all means, continue, right? But it's always nice to have alternatives, different tools at your request. Hey, Jody, how you doing? Hey, Gabriel, thanks for the follow. Sorry, I now kind of glancing at my comments there. Naya, Alisa, thanks very much. Quiet, 6 viewers, very cool. Hanifa go on way. Hanifa come back. All right. Okay. Now, again, when you're doing the exam, there's no need to work in multiple ways unless you want to check over your working, all right? But you can just check over your working step by step, line by line, right? And make sure it's making sense, right? Okay, cool. All right. DeAndre Donovan is giving a quick G figure with the green. Please and thanks. Right? If you need me to re-explain R. Okay, cool. All right, ladies, we okay with the purple and the green? Any issues, problems, questions? No? Okay. All right. Friends on this side, we okay with that? Problems, questions? We good? Good? All right. Okay. So I'll leave it there for a couple seconds again. Was there something I wanted to give you here, boy? Oh, right. I have a little add-on here. Right. So here, this is my little add-on question, right? So what is the gradient of a line that is perpendicular to the above line? Yeah. So that's the question, right? Why are you multiplying on both sides? Simply for right. So the basic rule is when you're manipulating equations and transposing, changing subject of a formula, when you have to kind of move things from one side to the next, what you're actually doing is you are using the opposite operation. Right? Let me give you an example, right, Flora? So let's say we had x plus 2 is equal to 3, right? If to solve for x, now you can ask yourself common sense. Some number plus 2 is 3. The only number you can add to 2 and get 3 is 1, right? Now, the other way to do it is where you have to remove whatever's attached to the item you're looking for, right? So if we have a 2 attached to the x by addition, we use the opposite operation. But the thing is, x plus 2 is 3, right? If we subtract or manipulate or affect one side of the equation, to keep it as an equation, to maintain equality, whatever happens to one side of an equation, it has to happen to the next side as well. So if you subtract 2 from one side of an equation, you have to subtract it from the next side. You can think of it like two siblings who, like, if you give one a particular gift, the next one has the same thing, right? So if you give this sibling a gift, this brother a gift, your younger brother wants the same thing, right? So whatever happened to one side of an equation must happen to the next side of the equation, right? Another example is, let's say you had 3x is equal to 15, and you want to solve for x. Now we know 3x means 3 multiplied by x, right? And the only number you can multiply 3 by and get 15 is 5. Alternatively, to solve for x by removing the 3, since 3 is attached by multiplication, we use the opposite operation, which is division, to remove the 3. And whatever happens on one side of an equation must happen on the other side. 3's will cancel. 3 into 3 goes one time, leaving us with x, and 15 divided by 3 is 5. Right? So I hope that helps at least a little bit, Flora. Okay, cool. Right, so what is the gradient of a line that is perpendicular to the above line? Right, so what do we say about the gradients of mutually perpendicular lines? Their product is equal to what? Product is crazy? The product of their, so when two lines are perpendicular, yes, they meet at 90 degrees, and the product of their gradients is -1. All right, you're welcome, Flora. And Stanaville, you're correct. Right, so what that means is that if we took the gradient of the line we're looking for and multiplied it by the gradient of the line we have, we'll get -1. So to find this gradient, you have to remove this thing. It's attached by multiplication. So to remove it, we use the opposite operation, which is division. If we were to do so on this side, it'll cancel with this. And whatever happens to one side of an equation must happen to the next side. All right, and of course, what's the protocol when you're dividing fractions? You change divide to multiply and you invert the divisor. And a minus by a minus will give us back a plus. Or like we said, flip it and change the sign. Flip it and change the sign. So 7 over 3, when you flip it, you get 3 over 7, and then it was negative, so now it'll become positive. I wanna add one more thing here, and then we'll let me just check the PDF real quick because there aren't too many more. We know on page 7. Oh, hold on. Okay, no, this is the John 2020. Okay, all right, we'll do this one. I'll come back to the other one just now, right? Sorry, let me just get the John 2021 going, right? Um, Beavis. Right, good, thanks. What the meow? All right, you. John 2021. John. Sorry, give me one sec. Ooh. Right. Insert. Screen clipping. All right, small thing. We'll deal with it. Oh, wait, I have the printer for you guys in class. Sorry, my bad. Why do I keep print? Print. Right. Current page. Moon Queen boy. No, no. No. You know? All right, so the straight line graph of x equal to 5 minus 3y intersects the x-axis at P and the y-axis at Q. Determine the coordinates of P and Q. So if it intersects the x-axis as the x-intercept, if it intersects the y-axis as the y-intercept. On the x-axis, y is always equal to 0. And on the y-axis, x is always equal to 0. Look, if you want to find the x-intercept, plug in y is 0 into the equation. But the y-intercept, you plug in x is 0 into the equation. Hey Ash, how you doing? You wish you were doing CSEC right now? Ash, what are you doing? Doing Cape or what? Or you in form for one hurry for CSEC? The 4 letters of it. Yeah, well, I'm trying to help. If I miss you, could check my YouTube channel. I have plenty of lives across there. But they will be coming down at the end of the month. So whatever you need to take a look at, check across there, right? Okay, so you're scrambling for eggs. 4 pieces of bacon. You're putting the egg, one cheese on top. That's slow. Um, Possibly fail. Well, failure is always a possibility. Yeah, you had to try. You had to try. As the saying goes, success is not final, failure is not fatal. It is the courage to continue that counts. So, depending on the messages you get in, that mightn't be much consolation because I know sometimes people over-index on success at particular stages in life. The truth is, and I'll be sure, I'll be real sure with you all. I did well at CSEC. It wasn't CSEC back then; it was just CSEC. I went to a pretty decent school, and I have friends who went to schools that do not have good reputations. And right now, all of them friends way more successful than me. All in living in the States. I have one who is a manager in Starbucks, driving a Porsche kind of thing, flying all over the place. I have the other one, Ian, he'll be checking all around the world. Not like in first class and then, he's taking connecting flights. And he's work from all over the world. Yeah. And then the other two, right? They mightn't be as well off, but they still live in a foreign country and do well and provide for themselves and their family. And they're on an upward mobility, on an upward trajectory. So success at any one stage is not final. You have to keep working. And failure at any one stage is not fatal. Unless of course you're really dead, which we're not considering as an option in this case, right? Yeah, you had to continue try. Sometimes when you feel it's hurt real bad, take some time, lick your wounds, and get back up again. So yeah, guys. So I had an ex friend. Yeah, length of the line is on the grid. It's basically Pythagoras. So okay, you know how in the gradient is the difference in the y divided by difference in x. Okay, so you're taking difference in x, squaring it, difference in y, squaring it, and you're adding them, and then you square root in that. All right, guys. Yeah, I'll give you the rest of the story in a little bit. I'm going to the question, right? Because we have a couple more to go and I'm watching the time. We did celebrate. Okay. Okay, so once again, the straight line graph of x equal to 5 minus 3y intersects the x-axis at P and the y-axis at Q. Page? Girls calling you. Right, okay. So when it intersects the x-axis, so again, that's the y, that's the x, right? At any point on the x-axis, no matter where on the x-axis, if you read across to the y, the coordinate is always 0. So if the line passes through the x-axis, to find the coordinates, you simply sub y equal to 0, right? Into the equation. So hold on. Right. So on the x-axis, y is equal to 0. So therefore, x minus 5, sorry, x equal to, sorry, my bad, 5 minus 3 by 0. Anything multiplied by 0, it'll give us back 0. 5 minus 0 will give us back 5. And look at that, x equal to 5. So if it intersects the x-axis at P, right, we get 5 on the x and 0 on the y. Similarly, right, on the y-axis, x is 0. So again, if you consider y, x, that. So at any point on the y-axis, if you read down to the x, the value you get is 0. So the y-intercept will always have an x-coordinate of 0. Hey, Tashina. Good to see you again. Hey, Sangita. Hey, Kalisha. All right. So on the y-axis, x is equal to 0. Right, so 0 would be equal to 5 minus 3y. Okay, so now what we could do to solve for y, you could carry over the 3y, right, by adding it to both sides of the equation, right? So again, if you want to see the longer version, anything that happens to one side of an equation must happen to the other side. So minus 3y plus 3y will cancel to 0, right? And then 0 plus 3y will just give us back 3y. And now to solve for y, you have to remove the 3. How is the 3 attached to the y? What operation? And to remove something attached from multiplication, we use, because it's the opposite operation, the inverse operation. So again, you can divide by 3 on both sides like that. Show the cancellation. Y is equal to 5/3. So now, for the point Q, x is 0 and y is 5/3. Right? And then they want the length of PQ. So there's a formula for length of a line, right? So the magnitude of a line, or the distance between 2 points, is given by the following formula. Right, so now you can do x2 minus x1 or x1 minus x2. It does not matter because you're going to square it anyway. And across here, you can do y2, sorry, plus, my bad, plus. y2 minus y1 or y1 minus y2, but you're going to square it, so it doesn't matter which one you do. All right, so again, you could have this as your x1, y1, and this is your x2, y2. So I'll give you a couple of minutes to sort that out. Sort that out. Right, be good. Sorry. Hey, Primacy, how you doing? All right, cool. So let's plug in those values. Right, and it said corrected 2 decimal places, so they specified the degree of accuracy they wanted it to use. All right, so again, you could do 0 minus 5 and then square, or 5 minus 0 and then square, it matters not, right? And then you could do 5/3 minus 0 then squared. All right, because then you have minus 5 squared. But when you square something, what are you actually doing? Multiplying it by itself. And whether you multiply a positive by a positive or a negative by a negative, you get back a positive. So minus 5 then squared is 25. And then that'll give us 25 over 9. Right. When we add those together, right, 9 by 25 is 225. Maybe I should show More work in there, right? Plus 25. Well, look at that. That just give us 25 by 9 and then plus 25. 5.27. All right, let's check it out. All right, so that's the roots of 250 over 9. Right, you can just plug that into your calculator. For those who want to see a little trick here, the square root of a fraction is the same as the square root of the numerator divided by the square root of the denominator. Right? Now, square root of 9 is very simple. That's 3. In the numerator, you could actually split apart a square root into like a product. Like, okay, 250 is the simplest way is 25 by 10. You could split that, right, like this. Now, this is just a little extra fanciness. This is not something I have to know. Although I have, this is, by the way, this is called working with surds. Surds being the square root items, right? So I have noticed them a couple times in this decade asking for stuff with surds. And as we know, root 25 is 5. So you have 5 root 10 all over 3. Right? Now that's the exact value, but they want it in 2 decimal places. So plug it in your calculator. So again, you could just do 250 divided by 9 and then square root. Right? 5.27, you're good to go. And whether you did that or you went all the way down and said, okay, 5 by the square root of 10, then divided by 3, same 5.27. Yeah. They have in paper 1. 99.9% probably not. But 0.1. Small. Uh-huh. 24. It was just like a previous paper. No, it wasn't a previous one. Okay. I asked my mom to do it. Okay. Why am I not surprised? Actually, was already good. All right, cool. Well, okay. Yeah. So once again, all of this extra stuff is this just extra. You don't have to do that. That's just me showing you something, right? Because they, like I said, they have been a couple questions within the last, it was 2019, John Boy. So I would say 6 years where you had to be able to simplify with surds. And that's the funny part. I don't feel like that's something explicitly stated on the CSEC math syllabus. The math people would know how to do that for sure. Or they should. You know. All right. More water. All right. All right. I'll give you a couple of seconds to copy that down and to ask any questions. Right. So we have about 20 minutes. We could do about 2 more questions if I have 2 more. Is that her name? Boy. All right. Oh, there was more? All right, whatever. But this was part of that question, 2022, right? Yeah. Yeah. John 23, John 23. Let me try this question here. Hold on. Yeah. Right. So last 2 pages here, boy. Okay, cool. Let's do that. Why is it selecting those two as well? Okay, cool. That's what I wanted. Yeah, sorry guys. Took a little while. I'll copy and paste these stuff in OneNote as well. So for those playing the home game, you should be able to follow as well, right? It'll take me a minute or two to copy and paste everything, right? So just bear with. So this is from Jan 2025, as a matter of fact. No. No. Hey, what are you doing across there? All right, hold on. Okay, cool. Those are some long sentences. Yeah, so everybody in a little slowness. So that, no, that's exactly what I didn't want. Okay, forget it. It's fine. All right, so let me just distribute stuff in class. I'll give you a lot of minutes. Last question. Tonight? Picking up from Krypton. When when electricity went on Krypton, was it Krypton? So right, so a line segment joins those 2 points, C and D. They want a midpoint. Right. So I'll help you out if you can't remember your formula, right? So midpoint, right, is x1 plus x2 divided by 2, and then y1 plus y2 then divided by 2. So the average of the x coordinates and the average of the y coordinates. And then on the gradient, we should know gradient by now. That's small m. Again, I don't know where the m per gradient come into play, but all right. I think g was gravity, so they couldn't use g again. Right, so that's the change in y. Divided by the change in x. Perpendicular bisector. Parallel and pass right on the equation. Right, okay, cool. Right, so I'll give you about a 5-6 minutes to get a little head start, and then like our Olympic thing and dive into it. Oh, it now makes sense. Interesting, interesting. Good. So for the gradients, you could do that. I would suggest you leave it as -1/3. You rounding off could create issues later on. Half point. Oh wait, did Ash ask a question? Guys, sometimes I think I don't see so many questions you'll ask it because clearly you all see something. I didn't see it because half point answering Ash. I'm not seeing Ash asking anything. So I'm not sure what's going on there. She said she wished she was doing. Oh, that was a while ago. Okay, cool. And you're asking her why? Maybe she didn't keep, and keep is a whole different beast. Yeah. Cool. All right, cool. All right, so let's jump in and see if we could organize some stuff there. Okay, so part A, they want the midpoint. So they want the midpoint of C, D. So I like to put the letters to the bottom right there, like a kind of subscript. You don't have to do that. That's not necessary at all. That's just my little personal preference, right? So we have x1 and x2. So we have -5 plus 7 all over 2. And then y1 and y2. 6 plus 2 all over 2. Right, so -5 plus 7 is 2. So we have 2 over 2. 6 plus 2 is 8. We have 8 over 2. That gives us 1, 4. All right, so that's the midpoint. Next thing they want is they want the gradient of the line segment, right? So, sorry, that bracket looking real bad. So gradient of CD, right? So again, so we could do y2 minus y1. So we have 2 minus 6 all over x2 minus, so 7 minus 5. And when you minus and minus, it becomes a plus. 2 minus 6 is minus 4. 7 plus 5 is 12. So you're correct. You have minus 1/3. Now, this is the part here. The equation of the perpendicular bisector of CD. What does that mean? Minus 5, 6, and 7, 2. Minus 5, 6, and 7, 2. You want an arrow. Right. So I want you to kind of just imagine with me for a second that this line here is the line CD, right? So that's C and that's D. The midpoint we got as what? It was 1, 4. So that's somewhere around here, right? The perpendicular bisect. So when two lines are perpendicular, they meet at right angles. To bisect means to cut it in half. So the perpendicular bisector cuts the line in half at a right angle. And they want the equation of the perpendicular bisector. That's a straight line. And one of the ways we can give the equation of a straight line is y equal to m by x plus c, where m is the gradient and c is the y-intercept. Now, again, perpendicular bisector means it cuts the line in half. To cut the line in half, it has to pass through the midpoint. So we have the x and y coordinates that we need. That's 4, that's 1. The gradient, so we did a couple times earlier today that if we have two lines which are mutually perpendicular, to find if we have the gradient of one, to find the gradient of the other, we divide minus 1 by the gradient we have, which basically means we flip it and change the sign. That's 3. 3 by 1 is just 3. We could subtract 3 from both sides of the equation and get 1 as the value of C, which means that the equation of the perpendicular bisector sorry, trying to write fast and neat. Right, equation of perpendicular bisector is y is equal to m, which is 3, by x plus c, which is 1. Can I go over that again? Which particular part halfway? Google Meet, I know I asked for this for about half an hour, but sorry about that. Right. But yeah, the answer's done. I'm going to give a quick G if you guys good with this stuff on the screen now, please. Yeah, so everybody 40-minute wait. Wow. I really do that way. Perpendicular. Right, okay. Yeah, so the perpendicular bisect. Let me get a little. Right. Y-axis, x-axis, origin. Let me see. Right. So that's point C. That's point D. The midpoint is about there, M, right? Right? A bisector is a line which cuts another line in half. All right? And perpendicular means it passes through the line at an angle of 90 degrees. Right? So if it passes through the midpoint, it means it passes through this point here. So you can use those points as they would lie on that line. And the gradient of, sorry, if we have the gradient of one of the lines and we want the gradient of the line which is perpendicular to it, okay, love vibes. Yeah, we simply divide minus 1 by the gradient we have. All right, we did that before a little earlier today. All right. Okay, and then the last part of the question, another line AB is parallel to CD. What does parallel mean? There's also a thing here with the gradient. When two lines are parallel, what does that mean for their gradients, ladies and gents? Their gradients are equal. Yes, they have the same gradient. They're equal. Good. And it passes through the point 0, 1. What do we notice about that pair of coordinates there? The x coordinate is 0, which means it lies on the y-axis, which means 0, 1 is the coordinate, or the coordinates of the y-intercept, which means the y-intercept is actually 1. So this question is actually the easiest one once you have everything else. So again, all we have to do is use y equal to mx plus c. Right, so y is equal to m by x plus c. Right, the gradient of the original line is the minus 1/3, and the y-intercept is 1 as given in the question. All right. Okay, folks, that's about it for the evening, right? I mean, I'm not going to cut off and run right away. We're here for a couple minutes again, right? Now, like I said, we switched tactics. So instead of going through paper by paper from 2025 Jan as far back as we could reach, we decided to do topic by topic, right? Now, give me 1 second. I want to pull up the schedule. What? Right. Sorry. Right. Okay. So we are here on Monday the 7th, right? So again, classes as per usual this week. Classes as per usual next week. As you can see, I have a POA crash course next week and the week after, right? Now, I have another, well, this is set up here, right? Don't worry with the extra POA crash course. That might change to a Form 6 crash course, but that's not for you. Anyhow, as you can see, we continue as per usual up to the 30th of April, right? That's right here. The day after April 30th is May the 1st. We officially in exam season at that point, if we're not there before, right? Because POA is a Tuesday, I'm gonna do as much POA as I can between the 1st and the 5th of May. Thereafter, right, after the exam, so if anybody here not doing POA, we can start earlier in the day. We could do math, we could start maths earlier, right? But basically, I'm trying to cram 10 sessions and 10 or more sessions between Tuesday, Wednesday, and Thursday. Now, if you have EDPM to do, if you have French to do, if you have TD, HSB to do, please study for your tests as much as you need to. I am not forcing you to be here. This is your exam season, right? It only comes once. Now, if you do keep, okay, fine. Flora, you see it? Okay, Flora, you had an email. Maybe we'll talk a little bit more, right? I have a whole YouTube channel dedicated to POA. You can find a real thing there. But email me, I'll see if I can help you out with some advice. Anyhow, yeah. So, like I said, this is your exam season. If you choose not to go to any lessons, that's your business. It's your season. If you know, hey, I know everything already, I need to focus and do what I had to do, cool. If you want to be here, cool. I'm not forcing anybody to be here. It's your season, right? Apart from that, yeah, as you can see, by the 8th, yeah, we basically done with maths. I mean, there will be multiple choice. The maths multiple choice is the very last exam on the 6th of June, which also says you're only really in exams for like 4 weeks, maybe 5 at most. That's it. Not even 6 weeks. Not counting orals, right? So as fast as it started, it's going to finish. Right? So of course they put English here, Geo and TD, Bio, Art Maths, that kind of stuff. But we could do paper ones that whole week, right? We could even start from the weekend before, although Art Maths people might be there, but I have Mishka handling the Art Maths people, so. But math multiple choice, honestly, guys, once you see like 4 papers, you see everything. It repeats, right? So Right, because you see, that's what they took sets off of the paper 2 since 2016. Right, but in doing so, people don't really teach it. So when it come in the multiple choice now, you know what to do, right? So we will be doing that stuff. And set theory is very important to math. It actually helps us to redefine and concretely define certain things in mathematics. Not that I know it very well, but yeah. All right. Anyhow, folks, that's about it for today. If anybody has any questions and they get to ask in class, please feel free to message me. All right. As you know, my time is a little hectic these days. I mightn't reply one right away, but send a message. All right. I think everybody on Google Meet gone, so I'm going to close on the meet. All right. YouTube, I'll go on there. Thanks for watching. So, do we have to pay for the period crash course? Yeah. It's 800 TT, but if you pay by next week Monday, you get 20% discount. So 640 for 32 hours a week. Yes, I do actually. Yeah, no problem. Yeah, Rise Grind, email me now. Or if you want Instagram, DM me, tell me this is Rise Grind from the YouTube Live.